Recently, I was in New Zealand asking the real tough questions.
Like, where did the Earth come from? Like, what was it before it was the Earth? Like, how did it get here?
I do not want to do this anymore.
Those who were game to answer my question realized that an explosion was important to Earth's formation.
I suppose it was created from space. I don't know. I don't know. Things that explode in space.
And I suppose just heaps of gas built up, bang, got a planet. Same with the sun and everything else.
So you're saying it came out of some sort of
I'd
explosion?
say it would have been gas, yeah. Would have been an explosion.
And then after that, there was just a planet there? Or?
That's a really good question, actually. I suppose it would be a whole bunch of gases, and then bang, a planet started evolving. All the gases were right.
Was there a particular explosion you had in mind? Perhaps one you learned about from a popular American sitcom?
From the Big Bang, maybe. Yeah.
The Big Bang.
The Big Bang Theory or something like that.
It was a bunch of dust that was formed during the Big Bang.
I've been to a couple of museums here in New Zealand, and then it all starts with the Big Bang, it says, and then you see a lot of volcanic action.
The Big Bang Theory. That's one of the theories of how Earth was created.
So the Big Bang created the Earth?
Yes.
It was like boom, and Earth was there.
Now, the trouble with explosions, which I was trying to hint at, is that they tend to blow stuff apart. They're more destructive than constructive, but what we're looking for is a mechanism to form the Earth, to bring things together. So how could the Earth form out of an explosion?
Masses that were then clustered together and compacted together and consolidated.
It was debris that gathered together through gravity.
Okay, where did that debris come from?
The Big Bang, I suppose, the original.
That big explosion led to a whole
Yes.
bunch of debris?
Yes.
And then it collapsed down
Exactly.
because of gravity?
Yes.
Now we're on the right track. The gravitational attraction between all mass is what causes matter to clump together into galaxies, stars, and planets. There's only one little problem. After the Big Bang, there were only two elements, hydrogen and helium, in the whole universe. So how could we form the Earth, including its oxygen, carbon, nitrogen, silicon, aluminium? I say it that way for my Australian viewers. How could we form all these other elements? Well, the truth is, the Big Bang didn't form the Earth, at least not directly. The Big Bang formed galaxies of stars. Let's focus in on one of these stars in particular, one whose contents will go on to form the Earth. In this star, the lighter elements are fusing together to form heavier elements, carbon, nitrogen, oxygen, and eventually all the elements up to iron. Now, when this star runs out of nuclei to fuse, it explodes. And out of that debris could form either directly our solar system or another star which then explodes and forms our solar system. So you could say the sun is a second or third generation star. And you might say, well, that would have taken a very long time to occur. And it's true. The Earth has been around for about 4.5 billion years, but the Big Bang happened 13.7 billion years ago. So if my arm span represents the time that the Earth has been here, then the Big Bang would be about here. You're doing a bang-up job, guys. So when people tell you that we're all made of stardust, they're not trying to be metaphorical or poetic necessarily. They're being literal. The iron in your blood was actually formed in the core of a star at millions of degrees. We and the world around us can only exist because of the elements that were formed in earlier stars.